All right. Be nice to whoever is in this room with you. Now, Unit 6, bivariate data. So here we're talking everything statistics. That's about it. Our mean, that is your average, right? So you're going to take all these numbers up, divide them by how many numbers there are, right? You guys know how to take averages. 40 plus 36 plus 52 plus 43 plus 59 plus 45, 45 plus 36 plus 52. Now, what I want you guys to do, get that number in your calculator. Just punch them all in. Then divide that number by the amount of numbers there are. We got 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 numbers. That I'm not going to do for you. You got to do that. That's about it, though. Now, for your median, the big thing is you have to put them in order first. So we're going to look for our lowest ones. I see two 36s. Go ahead and cross them off once you've done them. 36, comma, 36. Then we have a 40. That's our next one. 40. We have a 42, a 43, a 45, a 52, two 52s, and a 59. Now, what you're going to do is you're going to cross all these off one by one, right? You guys have done this before. Until you get to the middle. We have 43. Now, if you got one where you have two in the middle, you have to do the middle of those two. You'll take those two numbers and average them. So our median here is 43. If we're talking about mode, we are talking about like the frequency, how much you see a number. So I can see we have two 36s, two 52s. So you can have more than one mode. If you have something like that where you have two and two of two different numbers, then those are both your modes. So 36 is a mode and 52 is our other mode. Say we had 43 three different times in here. That would be the only mode. So you're talking about the frequency that you see a number. That's the biggest one. The biggest frequency, the biggest amount of times you see a number, that's what you got for your mode. Range. You are going to do your biggest number minus your smallest number. 59 minus 36. So you got to do that every time. 59 minus 36. You get 23. Do that with that one. All right, so let's see. Scatter plots, line of best fit. Determine whether the data would have a positive, negative, or no relationship. So if we're talking positive relationships, that means that our x and y are increasing at the same time. If it's a negative, as your x increases, your y will start decreasing. So let's look at this. A racer's bib number in a marathon versus their finish time. That shouldn't have any relationship. Oh yeah, or no relationship, right? Does your bib number matter where you're gonna finish? No. So no, I'm just gonna say R. The number of passengers on a flight versus the number of suitcases checked. So this would be a positive relationship because as our number of passengers goes up, our number of suitcases will also go up. All right, line of best fits. What I'm looking for here is really, is it a positive or negative slope? This is a negative slope, right? If it's going that way, right, that's a negative slope. So we know that this right there is a negative slope. I don't know what you guys have done in the past for this. Sometimes teachers will have you take literally 2 points, estimate them, do your slope formula for it. Doesn't look like we're doing that here. But what we do have is multiple choice options. You guys can't see this, my bad. Multiple choice options here. So we know that we have a negative slope it's either going to be -2/3 or 3/2. Now, if it was 3/2, then it would be pretty steep. If it's 2/3, then it wouldn't be very steep at all. This one's kind of a tough one, honestly. I hope they don't give you something like this on the test. I think it is the -2/3 because just if I look at my line, right, it's not perfect, but we're going over about 1.5 and down 1 each time, which makes me feel like it's 2/3. That one's a tricky one. Don't get too tripped up over that one. Use the line of best fit from part A to predict the balance of gallons credit, whatever, 15 months after January. So for this one, we need to look at our X and our Y variables. What are they telling us? Our X is months since January. Our Y is credit card balance. So they're asking what that credit card balance is 15 months after January. If this is months after January, all we have to do is plug 15 in for our X in our equation. So we have Y equals -2/3 times 15. The X value we're looking for, just be a little farther down over here, plus 12. All we're going to do is plug that into the calculator. So we have, remember, I like to do mine as 2 divided by 3 in parentheses, 2/3. Then we had, or -2/3 in parentheses, times 15. And then our y-intercept was 12. So plus 12. We get 2. So pick Gavin's credit card balance 15 months after January. It is 2. Oh, it's in thousands. So 2,000. Or you could write 2,000 in numbers too. That would probably be smarter. If they ever ask about a y-intercept, if you're trying to decide one of these, just estimate your y-intercept. It shouldn't be too hard. A lot of the times, I think they will probably just give you a point on the y-intercept that you can just use. All right. We have positive, negative, or no association. This one is a negative association. This one's a positive. This one is no association. It's no because it's completely scattered around. For D, kind of a tricky one. So it has an association, but it's just not like a linear association. It is negative on this side, but then positive on this side. So there is stuff in the real life that, will give you things like that. But yeah, there is an association, but it's just not a positive or a negative one. So what do we say here? Determine whether the association of positive, negative, or no association. Well, I don't want to say either of those. This has an association. It's not positive or negative. It's just not a linear association. I don't care what you put for that. All right. Ooh, two-way tables. Fun. These are not too hard. You just need to make sure you don't mess up, because if you mess up, then the whole thing is messed up. The Venn diagram below shows the results of a survey in which a group of students were asked if they play a sport or have a part-time job. So, of the students who play a sport, 10 of them also have a part-time job. And of the part-time job people, 10 of them play a sport. And then 7, I guess, didn't do any of that if that's outside the Venn diagram. That must be what that is. So, let's go total for sport. Let's do that real quick. Our total for sport is 18. Our total for part-time job, 15. Then we have job or no job. Wait, I messed up. At least I saved myself. First thing we got to do Well, it says part-time job, so the total of part-time job would go over here because that has no relation with it not playing a sport, right? Well, kind of, it might. We'll see. But we need to total up all of these to get our grand total. We have 18 plus 10 plus 15 plus 7. Now that is 50 people. Now we can figure out who's not playing a sport and who doesn't have a job. Yeah. So 50 minus 18, you get 32. 50 minus 15 is 35. Now we can fill in the inside. We have playing a sport and have a part-time job. That is 10. So we're going to go to sport. We're going to go to job. 10. Then I can just do math and figure out the rest of the table. How about we do that? These two columns are always going to add to your total. This is going to be 8. This, for the total jobs, we have 10. We know it has to be to 15. Add 5 onto there. That checks out. Here, if we're going from 5 to 32, or you could go 8 to 35, should be the same number. You can check your work that way. What you got to do is do what plus 5 is going to equal 32, or 32 minus 5. That is going to give you 27. Yes, 27. And then we're good. Hopefully I didn't do any of that wrong. This is my first time looking at this. Then let's see, what else do we have? Oh, we have frequency tables. So yeah. What you're going to do for your two-way frequency table. So if we were going to make a two-way frequency table out of this one, what you're going to do is you're going to get percentages of all of these. So what I would do is start with the total. So say this was a frequency table. They're asking you to do the one with the percents. You're going to find the percent all divided by 50. You're going to take all these numbers and divide them by the total. So you're going to get 32 divided by 50. That is going to be 0.64 or 64%. I'm actually going to, yeah, actually, no, you guys are fine. You're going to divide all these numbers by this, your total. Then what you're going to get is you should have these two adding up to 100. These two should add up to 100. And then it's the same thing. These two should add up to this one, and these two should add up to this one. So the only difference with the frequency table is that you are literally dividing it by all these numbers. So, right, or you're dividing it by your total. On this one, our total is 150. If we wanted to figure out the percent, 54 of 150, then we're just going to go 54 divided by 150. That's it. Then we're done. This is not a bad unit, guys. It's going to be a lot easier than what we did on Wednesday. Yeah, I am going to let you guys do the rest now. Stay in your seats. Be good.